Hi everybody, it's Miss Lorenz here. I'm going to go over some of the problems that you were assigned for the 1.1 section in topic 1. This is for 6th grade math. And so I've picked some of the problems to go over. It's not all of them because I don't want to make a super long video, but I've picked out the ones that have a tendency to cause the greatest problems for kids. So let's go ahead and go over those. Students, what I'd like you to do is have yourself something that you can correct your work with. Ideally, it's something that's a different color from what you use to do your work. So if you used a pencil to do your work, then I'd suggest a pen or a different colored pencil to correct your work. So you can see kind of what you did and then also make the corrections. So I certainly am not interested in just right answers. So please don't feel like you need to use a calculator and just get the right answer. I'm concerned that you understand what you need to do to correct your mistakes. That's where most of the learning is actually going to happen, is through that mistake process. All right, so I'm hoping that this is helpful. Let's go ahead and get started. We're going to go over 21. It's a subtraction with decimals problem. 22, an addition with decimals problem. 25, it's another subtraction with decimals, but this one has the troublesome 0 here, so I think we're going to go over that one as well. 25, it's more of a word problem. 30, sorry, did I say 25? 35. 38, because we have to apply something from this graph. We're also going to go over 41. It's a great thinking question. 42, and we'll also go over 43. So it's not that the rest of the problems that you were assigned are not important. They certainly are. It's great practice for you. These are just the high points for you to kind of do a spot check and see how you're doing on these concepts. All right, let's get started. I'm actually going to use a different color, so it will be differentiated for you guys. All right, number 21. We have 46 and 91 hundredths, and we're subtracting 28 and 7 tenths. So what I'm going to do is I'm going to rewrite the problem so that all of the place values are lined up correctly. So I have my ones lined up with my ones, my tens and my tens, my tenths and my tenths, and then I have a hundredth here. I don't have any hundredths here, but I'm going to annex a 0 or add a 0 here just because I want to make sure that I have some nice alignment. Of course, the most important part is that you're lining up your decimals so your place values are aligned. So I'm subtracting no hundredths here from 1 hundredth, so I have 1 left. I'm subtracting 7 hundredths from 9, so I have 2 left. I like to just bring that decimal right down. Here I don't have enough ones to subtract 8, so I'm going to go over to the 4. I'm going to take one of those tens and I'm going to unpack it. So now I only have 3 tens over here, but that 1 10, I'm going to bring it over here and add it to the 6 ones that I already have. So now I have 16 ones. Minus 8 ones is 8, and 3 minus 2 is 1. So I'm left with 18 and 21 hundredths. All right, number 22 is an addition problem. So same thing, I want you guys to make sure that you are rewriting these, lining up your decimals. And I'd also like you to practice reading them correctly. So what I mean by that is don't read this as 4.815, read it as 4 and 815 thousandths. And then we're adding to that 2 and 17 hundredths. I'm going to add another 0 here as kind of a placeholder. And then let's go ahead and add up what we have. So we're just going to add straight down. 5 and 0 is 5. 1 and 7 is 8. 8 and 1 is 9. I'm going to bring my decimal point down, and 4 and 2 is 6. So I'm left with 6 and 985 thousandths. Number 25 is that subtraction problem that I mentioned could possibly be troublesome for you because of that 0 sort of in the middle here. So as we rewrite it, I'm going to pay particular attention to make sure that I line up all of the places as they should be aligned. I'm also going to annex a 0 again right here. Sometimes you guys, kids think they can just drop this 0. You cannot drop this 0 if it's between numbers. Now, if it falls at the final end of a number that has a decimal like this, you can drop it. But if it's in the middle of numbers, you can't. So now let's go ahead and subtract. I can start here with my thousandths place, and I'm left with 1. Here I can't subtract 5 hundredths from no hundredths at all, so I have to go over to my tenths here. I'm going to take one of those tenths away, but I'm going to unpack it and create hundredths with those. So now I have 10 of those, and I'm going to subtract from 5 from that, and I'm left with 5. 4 minus 4 is 0, and 9 minus 9 is 0. So I'm left with 51 thousandths. You see how this 0 here, it's still holding that place to tell us we don't have any tenths. So we still read that as 51 thousandths. All right, number 35, one more subtraction problem. We're going to take 6 and 35 hundredths, and we're going to subtract 1 and 78 thousandths. Here I'm going to have to annex a 0 up top, and this one becomes really important because I need to be able to subtract 8 thousandths from some thousandths, and I currently don't have any thousandths. So I have to go over to my hundredths place, take one of those hundredths, unpack it into thousandths, and now I have 10 thousandths that I can subtract 8 from. So 8 from 10 is 2. I have to do the same thing here. I have to go to the tenths, take 1, unpack it, add 10 to that 4, so now I have 14. Minus 7 is 7. 2 minus 0 is 2. My decimal, and 6 minus 1 is 5. So I have 5 and 272 thousandths. All right, now we get to some multiplication. I have 13 and 99 hundredths, and I'm multiplying that times 7. So what we're going to do here is we are going to essentially ignore that decimal for right now. But over here on the side, we're going to think about, like, what do we expect this answer to be? So we're expecting 13 and 99 hundredths is close to 14, right? And then I'm just going to put this like thinking in parentheses. And then if we're going to think of what is 14 times 7, so that we can figure out what a reasonable answer would be. I know that 14 times 7 is 98. And so I'm expecting my answer to be around 98. Now I'm going to go ahead and multiply. Like I said before, we're essentially going to ignore that decimal, and I'll talk about why in a little bit. So 9 times 7 is 63. Again, 63 plus 6 is 69. 21 plus 6 is 27, and 7 plus 2 is 9. So that's the standard algorithm that you guys have already learned. Now we have to place the decimal. Remember, we started by estimating what we would expect our answer to be. So now there's only one place where the decimal would make sense. Somewhere that would be close to 98. So if I put the decimal here, that answer is close to 9 or 10. That makes no sense. If I put it here, it's close to 97 or 98. That would make sense. If I put it here, it would be close to 979. That would not make sense. And of course, it would not make sense here either, as that would be 9,793. So this is the only reasonable place, if we're using logical reasoning, for a decimal to be. The way that your book taught you is to count the number of points or places behind the decimal. So there are no places behind a decimal here, but there are 1, 2 behind a decimal here, so we would count those 1, 2 and make sure that that is where we place the decimal. All right, number 41. Number 41 is interesting because it's asking us to explain why this is only going to have one decimal place in the product. And so I'm really glad that this is on here, this question is on here, because if you just get in the habit of counting your decimal points and just putting a decimal where you counted it to be, then you could be missing out on what the reasonable answer should be. And so we have 25 hundredths here, and we're going to multiply that by 4/10. So we want 4/10 groups of 25 hundredths, or 25 hundredths groups of 4/10. I guess that probably sounded kind of confusing, didn't it? I'm going to multiply 25 hundredths by 4/10. Like I said before, I'm going to essentially kind of ignore those decimal points for right now. And then when I multiply, do you notice what I'm getting here? I'm getting this answer, 100. I know that 25 times 4 is 100, but now I'm looking at 25 hundredths times 4/10, and look at, if I count my decimal points, I have 3. I'm going to put the decimal here, and so my answer is 1/10, because these are no longer significant zeros since they are final zeros after the decimal, so we can drop them. So that is why we end up with only one place after the decimal here. All right, number 42 is looking at the hummingbird problem. So hummingbirds beat 50 times per second when hovering, and if a hummingbird hovers for 35.5 seconds, how many times do its wings beat? So this is 52 groups of 35.5. So we're going to go ahead and multiply. 5 times 2 is 10, 11, 7. Now remember, when you learn to do the multiplication standard algorithm, I think in 5th grade, maybe in 4th grade, you learned that you needed to have a placeholder here. And the reason we have a placeholder is because now we're going over to that 10th place. So we have to acknowledge that we're no longer in the ones place. We're now multiplying in the tens place. So we've got to move it over. So now we're going to go to the tens place. 5 times 5 is 25. 25 plus 2 is 27. And then 15 plus 2 is 17. And you guys, I'm kind of going through this quickly because I'm assuming we all understand the standard algorithm of multiplication. If we don't, if you did not get that last year or the year before, please do not feel badly about it, but tell me so that we can go through and review or reteach the standard algorithm. Okay, let's go ahead and take a look at, I need one decimal place, so I'm going to move my decimal over 1, and I am looking at, if I estimate, I'm going to think of 52 as 50. I'm going to think of 35 and a half. I want it to be a nice number. Let's think of it as 40. See how it's kind of close to 40? So if I think of it this way, 50 times 40, then I'm looking at an answer that's around 2,000. Is 1,846 around 2,000? Yes, it is. And so that's the only reasonable place where we would want to put a decimal. All right, and the last one I want to go over with you guys is 43. This is the popcorn problem, where students were selling the popcorn bins for $9.25 each, and they sold 42 of them. So I'm going to go ahead and multiply. You're going to notice that I'm always putting the number with the most digits on top, just so that it lines up a little nicer. Now I'm going to start by multiplying my ones place, my 2 times 5, my 2 times 2 plus 1, my 2 times 9. Again, my placeholder here, because I'm now moving over to the tens place, I gotta shift everything over. 4 times 5 is 20, 4 times 2 is 8, plus 2 is 10, and 4 times 9 is 36, plus 1 is 37. And then when I add my final numbers here, I have to acknowledge my decimals. So you can see I don't have any places after this decimal, but I have 2 here. So the rule would tell me that is where I need to put the decimal. Let's take a look at our numbers. 42, close to 40, right? $9.25. Let's make it easy for our brain and think of that as close to 10. What's 40 times 10? Well, 40 times 10 is 400. Is that going to be a reasonable place for the decimal? Is 388 and 50 cents close to 400? It is, because look at all the other places where you could put the decimal. Wouldn't make any sense, you guys. We're expecting it to be, near 400. If you put the decimal here, that'd be $3.88 or $38. That doesn't make sense. So that's the only reasonable place to put the decimal. So yes, you can count to double check, but I also want you to use reasonableness and reasoning in your thinking of decimal placement. All right, I hope that helped, and if you feel like you're ready, go ahead and sign up for a superset, and we'll go from there. Thanks for listening.